This presentation is about solving scheduling issues with machine learning, considering business and the solution analysis. The current problem is that scheduling shifts for employees and maximize preferences can take a manager hours each time. The managers will need to know each employee's available time, their preferred time to work, their total hours needed per week per their contract, and their roles. Evaluate upcoming workloads and determine how many employees need to work in certain roles in the next scheduled period. Pick the right people for the right job and enter them into time slots and maximize their preferred time and also meet their total hours per week requirement. At the same time, also keep it fair when some time slots are popular. Machine learning is a great tool to solve this problem because it is good at handling complex data. Multiple people, different shifts, preferences, and request time off are complex data, and they are trainable by patterns. Therefore, AI and machine learning is a great fit. This tool can save managers hours each time from creating a schedule and also maximize employee satisfaction. Next, we are going to go through business understanding on the CRIPS DM process. Managers who make shift schedules are the target users. The problem is that it's currently taking too long for each schedule. How it is solved today is managers are entering the schedules manually. And when there's request to change, swap shifts, managers also have to do it manually. So gaps are human manual work versus AI machine tool. Here are some quantified expectations from business savings. For a smaller organization with 10 teams, it can save around $16,000 a year. For a large organization like a hospital with 1,000 workers, it can save about $500,000 per year. Constraints of the tool includes the employees will need to enter all their data needed on time before the AI schedule can generate a actual accurate table. And the system may miss some data feature that can help generate more accurate results. And those data could be sensitive like religion, age, or health conditions. So we may or may not be able to get those data. Translate impact into matrix. The output is expected to be 90% accurate to help manager save their time, and the outcome should save managers time when they create a schedule. The target is that it can save manager at least 80% time compared to their manual work. Solution validation plan. The solution is to use machine learning to generate schedule for shift workers to make it very fast. And the output schedule should match at least 90% of manually generated schedule. Describe how you will execute a series of iterative experiments to validate. So I plan to use A/B testing on different models. Use customers to validate beta testing, and also time spent on a schedule output. Machine learning system design. We decide to use edge, offline learning, and online predictions. Employee ID and schedule are confidential data. Running on the devices could keep the data more secure than the cloud. And the device can be a local device or a company's intranet server. We choose to use offline learning because online learning has a high requirement for device and provides faster feedback. But our tool usually is used bi-weekly or weekly. Offline learning can retrain the system weekly and is sufficient enough, and it saves the company resources on data transfer bandwidth and device requirements. We're going to use online prediction because once all the data is ready and then the manager wants to generate the schedule, it needs to be generated pretty fast, not instant, but would need to be within half a minute, no more than a minute to make it more efficient. Two potential risks are considered in production. One is model risk, concept drift. When workers' preference changed from the time training data was provided, for example, young workers used to like to take overtime shifts to make extra money, but nowadays they no longer want to take additional work. Second is latency issue. When a large employees need to be scheduled at once, it may take the system a longer time to generate and reveal the best output and provide schedules. In this case, some data needs to be changed and regenerate it can take longer. It should not be a major concern since this tool should be more and more accurate over time and the managers are able to reduce the risk by scheduling in advance.